A Tale of Two Cities, New York and Tokyo. Imagine waking up in New York City on a bright Tuesday morning. The sun is streaming through your window, and your alarm clock reads 8 a.m. You're getting ready for work, school, or maybe a leisurely breakfast at your favorite cafe. Now picture yourself in Tokyo, Japan. It's 9 p.m. on Tuesday evening. The city lights twinkle as people head home from work or out for dinner. The streets are bustling with energy. Why is there such a difference? Why is Tokyo 13 hours ahead of New York City? The answer lies in the fascinating concept of time zones. Before the invention of standardized time zones in the 19th century, timekeeping was a decidedly local affair. Each town and village set its clocks based on the position of the sun. When the sun reached its highest point in the sky, it was considered noon. This method of timekeeping was deeply rooted in the daily lives of people, influencing everything from work hours to social gatherings. This system worked well enough when communities were small and isolated. People lived and worked within a relatively small geographical area. The local time was sufficient for their needs as travel was limited and communication was slow. However, with the advent of railroads and the telegraph in the 1800s, the limitations of local time became increasingly apparent. The rapid expansion of rail networks meant that trains could now travel hundreds of miles in a single day, connecting distant cities in ways never before imagined. Trains could now travel hundreds of miles in a single day, connecting distant cities in ways never before imagined. This newfound connectivity brought about a need for a more synchronized approach to timekeeping. Accurate communication became crucial, but with each town operating on its own time, coordinating train schedules and transmitting messages became a logistical nightmare. The discrepancies in local times led to confusion and inefficiencies, highlighting the urgent need for a standardized system of timekeeping. Enter Sir Sandford Fleming, a Scottish-Canadian engineer and inventor. Frustrated by the chaos caused by inconsistent timekeeping, he proposed a revolutionary idea, dividing the world into 24 standardized time zones. Each zone would cover 15 degrees of longitude. All locations within a given zone would share the same time. Fleming's proposal was met with initial resistance. Some people were reluctant to abandon their local time traditions, others questioned the need for such a drastic change. However, the practical benefits of standardized time zones soon became undeniable. Section 4. The Science of Time Zones, Earth's Rotation and the 24-Hour Clock. The concept of time zones is rooted in a fundamental astronomical fact: the Earth rotates on its axis. This rotation is what gives us the cycle of day and night, a phenomenon that has been observed and studied for centuries. It completes one full rotation approximately every 24 hours. This 24-hour period is what we commonly refer to as a day, and it is the basis for our 24-hour clock system. As the Earth spins, different parts of the planet face the sun. This constant movement means that at any given moment, different regions of the Earth are experiencing different times of the day. This is why we experience day and night. When one side of the Earth is bathed in sunlight, the opposite side is in darkness, creating a continuous cycle of light and dark. Because the Earth is a sphere, the sun doesn't illuminate all parts of the globe simultaneously. This spherical shape is crucial in understanding how time zones work. When it's noon in one location, it's sunrise in another, and sunset in yet another. This variation in time is what necessitates the division of the Earth into time zones. To account for this difference in solar time across the globe, we divide the Earth into 24 time zones. Each time zone corresponds to 1 hour of the 24-hour day. Each zone represents a 15-degree slice of the Earth's 360-degree circumference. This division helps standardize time across different regions, making global communication and travel more manageable. Section 5. Time Zones in Action, Business, Travel, and Global Communication. In today's interconnected world, time zones are essential for coordinating international business, scheduling flights and train travel, and facilitating communication across continents. Can you imagine trying to schedule a conference call with colleagues in London, Tokyo, and New York City if everyone was operating on a different local time? Time zones simplify these interactions, allowing us to connect seamlessly with people all over the planet. They are the invisible threads that keep our globalized world running smoothly. Section 6. The Quirks of Time, Half-Hour Offsets and Daylight Saving Time. While the concept of time zones is relatively straightforward, there are some interesting quirks and variations. Time zones are generally divided into whole hours, but not always. For example, some countries and regions observe half-hour offsets from standard time zones. These half-hour time zones are less common but still significant. Nepal, for instance, is 5 hours and 45 minutes ahead of Coordinated Universal Time, the primary time standard by which the world regulates clocks and time. This unique offset is a reflection of the country's geographical and cultural considerations. These half-hour offsets often reflect a desire to align more closely with the solar time of a particular region. By doing so, they can better match the natural daylight hours, which can be beneficial for daily activities and energy consumption. Daylight saving time is another interesting time-related practice. It involves adjusting the clocks forward by 1 hour during the warmer months. In many countries, clocks are moved forward by an hour during the summer months to take advantage of longer daylight hours and conserve energy. This practice can lead to longer evenings, allowing people to enjoy more daylight after work or school. While daylight saving time can be beneficial in some respects, it can also disrupt sleep patterns and cause confusion when crossing time zones. The sudden shift in time can affect our internal body clocks, leading to a temporary period of adjustment. Additionally, for travelers, navigating through different time zones can become more complex. Section 7. Time in the modern world, precision, and our interconnected lives. As technology continues to advance, our relationship with time becomes ever more precise and interconnected. Atomic clocks, the most accurate timekeeping devices ever invented, measure time with astonishing precision, losing less than a second every 100 million years. This level of accuracy is crucial for a wide range of applications, from GPS navigation systems to high-frequency trading on the stock market. In an increasingly digital world where milliseconds can make the difference between success and failure, precise timekeeping is no longer a luxury but a necessity.